Hello, we're here with Daniel Povey, and our first question is, um, I'm currently working on preparing the training data. I also have the following questions.
Mhm.
Question one, if I understand correctly, then the most common split of training data is 80% training, 10% dev, and 10% test. Does this depend on the size of the data set? I'm currently testing with 7,000 hours and distribute these 95 train, 4.5 dev, and 0.5 test. Is there a limit to the size of the dev data, or should always be 10%? Or is it perhaps even better to take more than 10%?
Uh, so traditionally, for a long time, test and dev sets were about 10 hours. More recently, because compute has got like faster, people have been using maybe 20 hours, maybe even more, 30 hours. But you don't really want to go beyond that because the noise gets very small, the noise in the testing, and there's too much compute for little gain. Yeah.
So, what do you suggest a person does with 7,000 hours?
Well, you could take 20-hour dev and test sets. I think it's maybe more important to make sure that the data doesn't come from like the same speakers and the same recordings as the training data than it is to make it large. You don't need it to be that large.
Okay, in development?
Yeah, same thing, like
Okay.
20 hours.
Okay, question two. Unfortunately, I had to reduce base LR a bit because I often get the warning grad scale is too small and the training stops at some point with the
Okay,
message runtime error. Is this due to too little dev data or what could be the problem?
firstly, this doesn't have anything to do with the amount of dev data. The amount of dev data won't affect this. And also, you shouldn't make the dev data too large because if we're using that to compute the validation loss, it does it with a certain periodicity, and you don't want to have too much there, I think. I don't recall what. Anyway, let me get to the main point about grad scale too small. Firstly, if there's any kind of instability, uh, or like training diverges, the way that will show up in our scripts is it'll say grad scale too small. At least it will do that if you're using half precision training, meaning use FP16 is true. That's the way it will fail. And often the failure has something to do with FP16 because in half precision training, it's much easier to get infinities either in the forward pass or in the backward pass. Uh, now, Now, one way to fix this is to just to not use half precision to set use FP16 false. That will sometimes resolve the issue if it was about the FP16. Uh, you can also reduce the learning rate. Uh, I I recommend that if you, let's say, halve the base LR, that you increase the LR batches by a factor of 4. That will uh, that will ensure that the asymptotic learning rate doesn't change. Because like if the error happens early on in training, let's say within the first 2,000 batches, it's more likely to be resolvable with by reducing a learning rate. Because too high learning rate will often cause failure earlier on. If it's another problem, like there could be a lot of reasons why the training failed. It's not just one thing, it could be many different things. Ultimately, the only way to tell is if you have like checkpoints or epochs saved to restart training from a certain checkpoint or epoch. I think you can use like start epoch or start batch to do that. And add the inf check flag, like minus minus inf check equals true. That will tell you something about where these infinities are coming from. Yeah.
Can you turn your video on?
Oh, when did I turn it off? Hmm.
In which cases should you use CTC head?
Ah. Okay, so I, I believe adding a CTC loss to RNNT systems generally increases like the robustness. It'll make a very small difference in memory and time taken during training, but very small. Uh, if you happen to have like very long transcripts for short recordings, there's a possibility, I think, that there could be some kind of crash due to that if there's CTC, because CTC does have a limitation that all the transcripts must have like fewer tokens than the recording length. Uh, I hope that's not an issue, but in general, I think it's fine to use the CTC head. You just have to maybe tune the CTC scale. It should help the RNNT results maybe a little bit, and it should also it makes it possible to decode with CTC later on if you want to.
Okay. Questions from the second YouTuber.
Hmm.
I'm currently learning about speaker embedding for their application in voice cloning. The first of the VC models is the speaker embedded model, which uses X vectors. I'm currently reading through Dan's papers, deep neural network, X vectors.
Hmm.
Question 4. I have the following questions, more so relating to the speaker embedding portion rather than speaker verification. The name X vector is first used in the 2018 paper. Would the previous DNN produced embeddings not be considered X vectors?
Yeah, I think X vectors and D vectors or whatever are basically the same thing. For some reason, either that previous work hadn't been published when we were doing it, or we were not aware of that work. It's the
Okay,
same thing.
how different are the core models between the papers?
Um, okay. So listen, if you're doing speaker identification with neural networks these days, you probably wouldn't be using Chaldean reality. Uh, the models have been moving on. So for a surprising length of time, someone created something called ECAPA TDNN, ECAPA TDNN. That was popular for a long time, and it seems to be the baseline still for a lot of speaker ID work. But I've seen people use transformers and stuff with some success. So you might just want to look at the latest ICAST proceedings if you can find it, or interspeech proceedings, and see what kinds of things people are using in the speaker ID session of that.
Hmm.
Yeah. Okay, let me read the rest of these
Is there a
questions.
meaningful difference between temporal and statistical pooling?
Oh, okay. So the pooling used in our papers was something where we compute the mean, but we also compute a standard deviation. And I've actually been surprised at the last ICAST conference that a lot of people are still using that even after many years. There seems to be something about it that works well for speaker ID. So even though they're using PyTorch-based setups, they're still using that, standard deviation thing. Uh,
Wait, oh, this one.
mhm.
Um, the 2007 paper added time delay and has one more hidden layer, but are they still network in network layers?
uh, I I don't know. Maybe I think this doesn't matter. Look for the eCappa TDNN implementation. That's something that people have been using as a kind of baseline for a long time, so it should be reasonable.
Okay, do you have any experience with voice cloning and do you have any resources to learn about it in a technical level?
Well, I do know that these days it's very easy to do this. Like people have published neural networks or at least APIs that let you do this very accurately. Uh, I haven't been following super closely this kind of stuff. Probably these days, any efforts at voice cloning are going to be using either flow or diffusion models, probably flow and some kind of transformers. Uh, Obviously, to understand neural networks generally, you should understand math and linear algebra and stuff, but I don't know. You should also learn PyTorch and learn about transformers and things like that.
Okay, do you have any more words about voice cloning or these topics?
Not specifically. I mean, voice cloning is like a very standard conditional generative task. So we're trying to generate some kind of sample, and it's conditioned on both the speaker and presumably the words they were trying to say, and maybe also some context if we want to clone just a portion of an existing utterance. So this kind of thing can be easily solved with transformers. Uh, yeah.
Hmm. Okay. Wait, let me think for a second.
Yeah, yeah.
Thank you. That was Daniel Povey.
Bye, thanks.
Bye.